Today we will be talking about the trigonometric functions of any angle. For that, we need to understand the standard position. So if the vertex of an angle uh, on the coordinate plane is at the origin and one ray is on the x-axis, then that angle is called in the standard position. So as you can see, we are extending the angle on the left-hand side of the screen, and x and y is the coordinate. So x-axis is working as the initial side. So in this case, let's say, let theta be an angle in standard position with x and y on the terminal side. So, and that terminal side from the point x and y to the origin is represented by r. So r is nothing but x squared plus y squared, because we are trying to find the distance from the coordinate x and y to the origin. Origin is 0 and 0. And we are making sure that r is not equal to 0. The reason is because the distance cannot be 0. So a radical of x squared plus y squared, it is just a distance between the two coordinates, x, y, and 0, 0. Okay, now as you know, the distance formula is x2 minus x1 whole squared plus y2 minus y1 whole squared inside the radical. But why we are using only x squared plus y squared? Because the another coordinate is 0 and 0. So basically x minus 0 whole squared plus y minus 0 whole squared, right? So sine is nothing but opposite over hypotenuse, right? So if I construct a triangle, a rough triangle with theta as one of the acute angle in that triangle, then r is nothing but the hypotenuse. Then we have the y-axis and the x-axis. So sine is nothing but sine theta is y over r, because opposite over hypotenuse, and cos is x over r. In a unit circle, r, that means radius, is considered as 1. That is why we say sine theta is represented by y, cos theta is represented by x, because it is as per definition. When we are talking about the tangent theta, it is y over x, provided x is not equal to 0. Now we can quickly write all the counterparts. Cosecant is the reciprocal of sine. Secant is reciprocal of cosecant of cos function. And cot is the reciprocal of tangent function. And we need to be careful wherever there is a denominator that the denominator should not be equal to 0. Now, the distance is always positive, because r is nothing but the radical of x squared plus y squared, and it cannot be equal to 0 Therefore, sine and cosine functions are defined for any real number or real value of theta. Tangent and secant are undefined when x is equal to 0, and on the On the same hand, we can say cot and cosecant are undefined when y is equal to 0. Let's take one example. Let's have a coordinate plane. We have the initial side, and then we are creating an angle. And the another ray is called terminal side. So this angle is theta. Let's say we have a point on the terminal side as negative 4, 5. Let's take another coordinate. So let's take negative 3, 4. So r is equal to radical of x squared plus y squared. So x is negative 3 and y is 4. And if you put it in the equation, you will get r as just 5. So r is nothing but the distance. If we have a right triangle, that works as the hypotenuse. So sine theta will be equal to 4/5 because that is opposite over radius or opposite over hypotenuse. R is nothing but the radius on the unit circle. And the same way we can write for cos and tangent as well. Okay, moving forward, let's have another coordinate plane. On this coordinate plane, I know in the first quadrant, x and y both are positive. In the second, we have x negative. In the third, both x and y are negative. And then in the fourth, x is positive, y negative. We call it as an acronym ASTC. That means in the first quadrant, all are positive. All trig ratios are positive. In the second quadrant, only sine is positive, because if sine is positive, cosecant is positive. In the third quadrant, only tangent is positive, and because tangent is positive, cot is positive. In the fourth quadrant, only cosine is positive, because cosine is positive, secant is also positive. So ASTC can be remembered in two different ways. All students take calculus. That is one way of remembering this mnemonic. Or add sugar to coffee. So whatever works for you, you can go for it. But remember ASTC, and that will help you to understand in which quadrant which trig ratio will be positive and which trig ratio will be negative. Okay, so let me write cosecant, cot, secant, and they are also positive in those quadrants. Apart from these positive trig, others will be negative. Okay, let's take one example. So we have sine theta is equal to 4/5, and it is given that tangent theta should be less than 0. And we need to find out what is cos theta. Now, few things we need to keep in mind. When they are saying tangent theta is less than 0, in which quadrant tangent is negative? So if you look at the chart, in quadrant 1 and quadrant 3, tangent is positive. So second and fourth, those are the quadrant where tangent is negative. If I look for the sine theta, in which quadrant sine theta is positive? Because it is 4/5, it is positive. So it is positive in first and second quadrant. So out of sine theta and tangent theta, which quadrant matches? Quadrant 2. So we are taking quadrant 2. So if we have to write the solution, so sine theta is opposite over hypotenuse. So I can write 5 as the hypotenuse, and if I use the Pythagorean triple, we have 3, 4, 5. I know x will be 3. So we have all the side lengths. Can I write the cos ratio? What is cos ratio? Cos ratio is adjacent over hypotenuse. The other way to understand is using a Pythagorean theorem. So hypotenuse is 5, one side length is 4, that will give you x is equal to 3. So cos theta will be 3/5. Okay, let's move on. Let's talk about reference angle. So reference angle, as simple as we can say, this is the left over with the x-axis. So what angle is left over with the x-axis after we create the original angle? So let's take 3 different scenarios. To represent 3 different reference angles. In the first one, we are having an angle that lands at the second quadrant. So what is left over with the x-axis? This yellow shaded part is left over with the x-axis, and let's call it as alpha. Then in the next example, we are landing the angle in the third quadrant. Now this is very tricky. So we are done with 180 degree. Now how much is more from the 180 degree? That is the yellow part, yellow portion. And that yellow shaded part is called alpha. That is called the reference angle. So reference angle deals with 180 degree and 360 degree. So if it is closer to 360 degree, we are taking that. If it is closer to 180 degree, we are taking that. In the third example, it is closer to 360 degree. So how much it is left to reach 360 degree? Alpha is left. So alpha is nothing but the reference angles. Now, for the first two, we can say 180 degree minus theta because it is closer to 180 degrees, right? Or in terms of radians, pi minus theta. For the third option, it is 360 because it is closer to 360 minus theta. What is left over theta? Or in terms of radian, 2 pi minus theta, or you can say theta minus 2 pi. But 2 pi minus theta would be the right way to represent. For the second option, instead of writing 180 degree minus theta, because theta is greater than 180, we can say theta minus 180 degree or theta minus pi. So this is what the reference angles are. Let's take one example. So theta is given as 2.4. Find reference angle. Now here's the thing. Theta is just standing alone as 2.4. It, it doesn't have a pi symbol to represent the radian. It doesn't have a degree. So when it doesn't say specifically, we consider theta as radians because there is no degree symbol. Because pi over 2 is approximately this value and the pi is 3.1416 and we are talking about theta as 2.4. So that means it should lie between pi half and pi. That means the quadrant should be 2. So if I construct it, always make a rough sketch of the angles. It will give you a good idea. Now, what is left over? This shaded area is left over. So pi minus 2.4. That will be the reference angle. Let's calculate it. It will give you the value of 0.7416. That is the leftover part. Okay. Now, moving forward, let's take one more example. Let's theta is negative 155 degrees. Now it's specifically mentioned a degree symbol. So it is a negative, so it will go clockwise. And when it goes clockwise, it is less than 180. So it will land in quadrant number 3 because we are going backwards. So ask yourself how much is needed with 155 to get to 180. Forget about the negative sign. Negative sign was there just to represent the angle, whether it is going clockwise or anti-clockwise. So alpha will be 180 minus 155, and that will be 25 degrees. So I hope reference angle was clear. After this, let's create another coordinate plane. Now we have another angle. Now we have theta and alpha. And if we have another point, let's say negative x comma y. Why negative x? Because it is in the second quadrant. And in the second quadrant, x is negative. So from this point to the origin, that distance is r. And if I create a triangle, so I know sine theta is y over r, and sine alpha will be absolute value of y over r, opposite over hypotenuse. So the main idea is if I calculate sine theta or sine alpha, the value will approximately be the same. Now, common trig values of common angles So let me make a table, and it is a good idea to understand this table. So 0 degree, 30 degrees, 45, 60, and 90. So these are common angles and for the first quadrant. In terms of radians, So let's write all the values down. Let's make a table, proper table. So sine theta, cos theta, and tangent theta. So we know that sine theta is 0, 1 half, radical 2 over 2, radical 3 over 2, and 1. Now after this, if I rewrite it backwards, that will become the values for the cos theta. So we ended sine theta with 1 for 90 degree. Now start cos theta with 1. And all the values will line up. Now these are the values of cos. Tangent is nothing but sine theta over cos theta. So divide sine theta over cos theta. So what is 0 over 1? 0. 1 half divided by radical 3 over 2 will give you radical 3 over 3 because we need to conjugate. Then we will get 1 for 45 degrees, and for 60 degrees it is radical 3 and then undefined. So these are the basic values of sine, cos, and tangent. So if you just memorize for the sine, it will work. In fact, you don't need to memorize it. You have learned in geometry 35 at 30, 60, 90 triangle, 45, 45, 90 triangle. These values are from there only. Now, how to use the reference angle to evaluate the trig functions? Let's take one example. Okay, so I think it is getting laggy. Just give me 1 second. Okay, now it's working again. So tangent 11 pi over 6. So can I rewrite 11 pi over 6 again as a fraction? So 11 pi over 6 will be 12 pi over 6 minus pi over 6. Because 12 pi over 6 will give you 2 pi, which is a complete circle. So pi over 6 is nothing but your reference angle. And if you go back and look at the table, you can see what is tangent of pi sixth. Let's create the angle first. It will land in the third quadrant. And in the third quadrant, tangent is negative. So we need to keep that thing in mind. That is why sketching the angles are very, very important. And you can see we got the answer as negative pi 6. That means the angle, we are looking for the negative values. So negative of tangent pi over 6, if you look at the table, pi over 6 is radical 3 over 3. That will be our answer, negative radical 3 over 3. Right? So the few things that you need to keep in mind, sketch is important because with sketch you will be able to identify where your angle will land, and in that particular quadrant what is positive, which trig ratio is positive and which trig ratio is negative. Because if you just write radical 3 over 3, that will be a wrong answer because it landed in the fourth quadrant, it is negative. Let's take one more example. So we are using calculator to evaluate. So cosecant 5 is given. Again, there is no degree is given. So we will take 5 as pi radians. It is considered as radians. Now I can write cosecant as sine 5 x to the power of -1. You can type it in the calculator and click enter. So be careful with the parentheses because when you type it in the calculator, the parentheses are very, very important. If the parentheses are not there, you will get some funky answers. So the final answer will be negative 1.042835. Now another example, let's evaluate f of t is equal to tangent t for t is equal to 7 pi over 3. Now it also says which corresponds to the point 1/2 comma radical 3 over 2 on the unit circle. So if you know how to make a unit circle, you know what they are talking about. 1/2 comma radical 3 over 2. What pi radians or what degree they are talking about. Now, keeping the same thing in mind, let's take a look at the unit circle again. So, as the real number line is wrapped around the unit, no, my mistake, around the unit circle, each real number corresponds to a central angle. And so central angle, that means we are assuming that it is in the standard position. That means its vertex is at 0, 0. So where radius is 1, because the unit circle implies that the radius is 1. We also know that S, which is the arc length, is nothing but the r times theta, which is a directional length. So because when r is 1, arc length is nothing but the theta. So theta is always measured in radians. Now let's have a circle. Let's have a coordinate on the circle. And let's have one point T, which has a coordinate of x and y. And if I connect the point T with the vertex, that is nothing but the radius. And then we have angle theta. So to understand this, if you remember in geometry when you used to represent the triangle, triangle has the three vertex, right? A, B, and C. So in the same way, T is just a point on the triangle. So now coming back to the question again, they said f of t is equal to tangent t and t is 7 pi thirds. So let's create 7 pi thirds where it will land. So if we have a point t that is 1/2 radical 3 over 2, again, if you have a good understanding of the unit circle, you know what pi radians they are talking about. And if I construct a right triangle, that's how it will look like. So radical 3 over 2 is nothing but the y-axis and 1/2 is the x-axis. Because tangent is sine over cos or y over x. So 7 pi thirds can be rewritten as 6 pi thirds, because 6 pi thirds implies that the whole entire circle is covered, and then adding pi thirds. Now again, you can see we are adding pi thirds. That means it is positive, and tangent is positive in first quadrant. It is also positive in the third quadrant, but for the third quadrant, the coordinate will be negative. In this case, 1/2 and radical 3 over 2, both of them, they are positive. That also indicate that it is in the first quadrant. Okay, I lost my page. Okay, here we go. So you can see from here what again the table is and how we can use this table more efficiently. So tangent pi thirds from the table is radical 3. So this is their way of asking you what is tangent pi thirds. So if you just understand the first quadrant of the unit circle, you can figure out any angle from the unit circle, provided are 30, 60, 90, and so on. So if I do y over x, it is radical 3 over 2 divided by 1/2. After this, we need to write some important points, because in the next lesson, we will be learning how to graph sine and cosine function. So the first important point is to understand what is the domain. Domain of the sine and cosine function is the set of all real numbers. Range Since by definition sin t is equal to y and cos t is equal to x comma y coordinate is on the unit circle and y ranges from -1 to 1 and x also ranges from -1 to 1 because remember sine and cosine function, they oscillate. It is just like a spring. It keeps on going up to 1, going back to -1. It keeps on jumping back and forth. So that is why sine and cosine also range from -1 and 1. So the second important point is the periodicity. So periodic functions are what that ranges within a particular period. So sine and cosine has a period of 2 pi. On the other hand, the tangent, it has a period of only pi. Why it has a period of pi, we will talk about it later, but because the tangent has a vertical asymptote at pi over 2. So sine and cosine are periodic and have a period of 2 pi. The period of tangent is only pi. Even and odd function, this is also very important. So if I categorize into two, even and odd, cos function, that means cos of -t, will give you cos t. And on the same hand, secant of -t will give you positive of secant t. Because if cos is even, secant is also even. For odd function, sine is odd function. That means sine of -t will give you negative of sine t. And because sine is odd function, cosecant is also odd function. And because sine is odd function, tangent is also odd function. And because tangent is odd function, cot will also be odd function. Because cosecant is the reciprocal of sine and tangent and cot both involves sine. That is why they are odd function. So this is the whole entire gist of this unit 6.3 right triangles. I hope it will make sense and I will see you in the next video. Bye-bye.